Hello, so welcome to this lesson about confidence interval. So in fact, confidence interval is just another methodology to test or check our hypothesis. So let's see what is confidence interval and how can we use them to test our hypothesis. So now suppose we have this normal distribution. We have seen that using a confidence level, for example, of 95%, in our case, we have two-sided test. So we have here alpha over 2, which is 2.5%, and here we have 2.5% also to the left, which is also alpha over 2. So in fact, a confidence interval is the range of the values that we are confident around the mean value at a specific confidence level. So in fact, in between here we have the acceptance region, which is 1 minus alpha. So if we have alpha to be 5%, we have 1 minus alpha to be 95% of confidence. So in fact, the interval is only the interval of the acceptance region in the white area. So we are going to construct the confidence interval to represent where are we confident about the values of the mean. So let's have a look what we are going to do. Now we are going to construct an interval around the mean. So the mean value will be bounded by some lower limit and upper limit. So if the mean value lies in this interval, we will fail to reject the null hypothesis, as we are going to see soon. So if the mean value lies in the acceptance region, we have a probability that happens to be 1 minus alpha. For example, if alpha is 5%, we have a probability that this happens as 95%. Okay, so we have seen before this limit in the upper limit to be z alpha over 2, which is the point where the area under the curve, and to the right of this point is alpha over 2. And this value is z 1 minus alpha over 2, in which the area to the left will be alpha over 2, or area under the curve to the right of this point will be 1 minus alpha over 2. So we have seen that the area in between will be 1 minus alpha. So we have the probability that z0 will be between these two values equals to 1 minus alpha. But we know that z0 is our test statistic, which equals the difference between the sample mean and the hypothesized population mean divided by sigma over square root of n. So in fact, we can rearrange and substitute by z0 here and rearrange these inequalities, and finally and eventually we will get this formula. So we have the mu to be bounded between upper limit and lower limit. We have the probability that mu lies in this interval, which is equal 1 minus alpha. So simply, the confidence interval is given in this equation. We have the confidence interval on the population mean to be bounded by the upper limit, which is x bar, the sample mean. We have z alpha over 2 and sigma, if we know sigma. In our case, we know sigma, which is the population standard deviation, and here square root of n, and n is the sample size. On the other side, we have the same values, except we have minus here instead of a plus. So in fact, this inequality we can have less or equal or only less. We have here larger or equal or only larger, as we have seen here. So we can put the equality sign or don't put the equality sign, the same will be our results and conclusions. So let's have an example. We have from the previous example about the capacity of water bottles. We had z alpha over 2 to be 1.96. Also we have the sample mean x bar to be 499.71. We have the sample size to be 9 elements or 9 bottles. We are aware of the population standard deviation to be 2 or sigma 2. Now let's construct the 95% confidence interval. So we will use the same interval or the equations here. We know x bar, we know z alpha over 2, we know sigma, we know n. So we can compute all these values to get the confidence interval. So now this is our confidence interval. So what does it mean? Now we are 95% that the mu can be included in this interval between 498.404 and below 501.018. But what happened? In fact, we have the mu naught, or our hypothesized value for the mu, to be 500 milliliter. So if we look for the 500 milliliter, in fact the 500 is included within this interval. So we have the mu naught, which is 500, is larger than the lower limit and below the upper limit. This means mu naught is included inside the interval. So our conclusion that we will fail to reject H naught. So the bottle capacity statistically is still the same at 500. So the other conclusion, to reject the null if we have the mu naught outside these limits. For example, if the mu naught was larger than this value or mu naught was less than this value, we will reject the null. But here in our case, we have a mu naught equal 500. The 500 is included in our confidence interval, so we fail to reject H null. We fail to reject H naught, which is the null hypothesis. So now our conclusion is that we fail to reject H naught. So the mean value of the water bottle capacity is still at 500 and has not changed to any other values.